January 17, 1942, Washington, D.C. The corridors of the War Production Board building hum with a tension that no amount of cigar smoke can mask. Outside, frost clings to the bare branches of the Capitol's trees. Inside, a room full of engineers and military planners sit in silence, staring at a map of the Pacific. Red pins mark Japanese conquests, Singapore, Manila, the Dutch East Indies. Each pin represents not just territory lost, but something far more vital. Rubber, natural rubber. The black gold that keeps every truck rolling, every plane flying, every warship sealed against the sea. In this room, the men know a terrible truth: America has just lost access to 90% of the world's natural rubber supply. And without rubber, the greatest industrial nation on earth cannot fight a modern war. One engineer, a man named William Jeffers, sits with his head in his hands. He is not a man given to despair, but the numbers before him are unforgiving. The United States military needs 600,000 tons of rubber per year to sustain operations. The stockpiles will last 6 months, perhaps 8 if rationed brutally. After that, the tanks will stop. The bombers will be grounded. The jeeps, the ambulances, the entire mechanized backbone of American power will seize up like an engine without oil. Jeffers looks up, and his eyes are red. He is not alone. Across the table, other men wipe at their faces, pretending it is only the smoke. But it is not smoke. It is the weight of impossibility. For decades, the United States had built its industrial empire on a foundation of natural rubber tapped from the Hevea brasiliensis tree, grown in the plantations of Southeast Asia. The British controlled Malaya. The Dutch controlled the East Indies. Together, these colonies produced more than 90% of the world's rubber, and America consumed more than anyone else. Rubber lined the fuel tanks of B-17 bombers. It sealed the hatches of submarines. It cushioned the landing gear of fighter planes. It insulated the wiring of radar systems. It formed the treads of every vehicle tire, from the smallest jeep to the largest tank. Rubber was not a luxury. It was the circulatory system of modern warfare. And in the winter of 1942, that system had been severed. The Japanese advance through Southeast Asia had been swift and merciless. On December 7, 1941, the same day Pearl Harbor burned, Japanese forces began their assault on British Malaya. Within weeks, the rubber plantations of the Malay Peninsula were under enemy control. By February, Singapore, the fortress of the East, had fallen. The Dutch East Indies followed in March. With clinical precision, Japan had seized the rubber supply of the world, and in doing so, had placed a noose around the neck of American industrial might. In Tokyo, military planners allowed themselves a rare moment of satisfaction. They believed they had struck a blow from which the Americans could not recover. They believed that without rubber, the United States would be forced to negotiate, to compromise, perhaps even to surrender its ambitions in the Pacific. They were wrong. But in January 1942, no one in Washington could yet see how. The crisis was existential. Military planners drew up scenarios, each more grim than the last. If the rubber ran out, the United States would have to choose which vehicles to keep running and which to abandon. Would it be the bombers or the tanks? The transport trucks or the ambulances? Every choice meant death. Every choice meant defeat. President Franklin Roosevelt understood this. In a meeting with his cabinet, he spoke quietly but with an edge of steel. "Gentlemen," he said, "we are going to lose this war if we do not solve the rubber problem. I don't care how. I don't care what it costs. But we will solve it." He paused, then added, "or we will lose everything." The American public was not yet fully aware of the depth of the crisis, but they would be soon. In the spring of 1942, the government launched a nationwide rubber drive, urging citizens to donate old tires, rubber mats, garden hoses, anything that could be reclaimed and recycled. Children went door to door collecting rubber bands. Housewives turned in their rubber girdles. The scrap drives brought in hundreds of thousands of tons of old rubber, enough to buy time, but not enough to win a war. Recycled rubber was brittle, inconsistent, prone to failure under stress. It could patch a tire, but it could not build a bomber. The engineers knew this. The military knew this. And so the search for an alternative became the most urgent scientific mission in America. The idea of synthetic rubber was not new. German chemists had experimented with it during the First World War, producing a substance called methyl rubber that was inferior to natural rubber in almost every way. It cracked in the cold. It melted in the heat. It lacked elasticity and durability. But it was rubber, of a sort, and in the desperation of 1918, the Germans had used it. After the war, the research continued, slowly, quietly, in laboratories in Germany and the United States. By the 1930s, a few experimental synthetic rubbers had been developed, neoprene, Buna-S, Buna-N, but none had been produced on an industrial scale. The cost was too high. The quality was too inconsistent. And as long as natural rubber flowed freely from the plantations of Asia, there was no incentive to invest in an unproven technology. But Pearl Harbor changed everything. In early 1942, the War Production Board assembled a panel of the nation's leading chemists, engineers, and industrialists. Their mandate was simple: create a synthetic rubber industry from nothing, and do it faster than anyone thought possible. The man chosen to lead this effort was William Jeffers, the president of the Union Pacific Railroad, a blunt, no-nonsense executive with a reputation for getting things done. Jeffers was not a scientist. He did not understand the chemistry of polymerization or the molecular structure of butadiene. But he understood logistics. He understood deadlines. And he understood that failure was not an option. "We're going to build this industry," he told his team, "and we're going to build it in 1 year." The scientists looked at him as if he had lost his mind. Building a synthetic rubber plant required petroleum feedstocks, specialized equipment, chemical reactors, miles of pipeline, and a workforce trained in a technology that barely existed. It required coordination between oil companies, chemical manufacturers, construction firms, and government agencies. It required breakthroughs in chemistry that had not yet been made. 1 year. It was madness. But Jeffers did not flinch. "Then we'd better start today," he said. The first problem was the raw material. Synthetic rubber is made from petrochemicals, specifically butadiene and styrene, both of which are derived from petroleum or natural gas. In 1942, the American oil industry was geared toward producing gasoline, not chemical feedstocks. The refineries would have to be reconfigured. New cracking units would have to be built. The oil companies resisted at first, citing cost and complexity, but Jeffers did not negotiate. He went straight to the top, to the oilmen who controlled America's energy supply, and he made them an offer they could not refuse. The government would guarantee contracts, provide funding, and ensure that the synthetic rubber plants would be built alongside their refineries. And if they refused, Jeffers made it clear, the government would build the plants itself and take over their operations. The oilmen agreed. Among them was a name that would become central to the story: Rockefeller. The Rockefeller family had built its fortune on oil, and by 1942, Standard Oil of New Jersey, later known as Exxon, was one of the most powerful corporations in the world. Standard Oil controlled the patents to a German synthetic rubber process called Buna-S, which it had acquired through a licensing agreement with the German chemical giant IG Farben before the war. This agreement was controversial, even scandalous, and it would later lead to congressional investigations. But in the desperate spring of 1942, the controversy did not matter. What mattered was that Standard Oil had the knowledge, the patents, and the refining capacity to produce butadiene on a massive scale. And so the Rockefeller empire, built on the oil wells of Pennsylvania and Texas, became the engine of America's synthetic rubber revolution. The chemistry itself was elegant in its complexity. Natural rubber is a polymer of isoprene, a hydrocarbon molecule with 5 carbon atoms. Synthetic rubber mimics this structure by polymerizing butadiene, a molecule with 4 carbon atoms, often in combination with styrene to improve durability. The process requires high heat, high pressure, and precise chemical catalysts. In 1942, American chemists understood the theory, but the practice was full of unknowns. How much heat? What pressure? Which catalysts? Every variable had to be tested, adjusted, and tested again. Mistakes were costly. A single miscalculation could ruin an entire batch, wasting thousands of gallons of precious petroleum. But there was no time for caution. The plants were being built even as the chemistry was being perfected. Engineers and chemists worked side by side, improvising, adapting, racing against a deadline that never stopped moving. By the summer of 1942, the first synthetic rubber plants were under construction. The largest was built in Institute, West Virginia, on the banks of the Kanawha River, operated by a consortium of chemical companies led by Standard Oil. Other plants rose in Texas, Louisiana, and California, near the oil refineries and petrochemical complexes that fed them. The construction was brutal. Workers labored in the sweltering heat, erecting miles of steel piping, pouring concrete foundations, welding reactors the size of houses. The pace was relentless. Jeffers visited the sites constantly, demanding progress, accepting no excuses. When one contractor told him that a critical piece of equipment would take 3 months to fabricate, Jeffers replied, "You have 3 weeks." The equipment was delivered in 2, but building the plants was only half the battle. The synthetic rubber they produced had to be tested, refined, and improved. The first batches were failures. The rubber was too soft, or too hard, or it cracked under stress. Tires made from early synthetic rubber blew out after a few hundred miles. Seals leaked. Gaskets failed. The military rejected batch after batch, sending the engineers back to the laboratory. The frustration was immense. Men who had worked for months without sleep broke down in tears. Some quit. Others drank themselves into oblivion. But most stayed. They stayed because they knew that somewhere in the Pacific, American soldiers were fighting with equipment that was literally falling apart, and the only thing that could save them was the rubber that had not yet been invented. The breakthrough came in late 1942. A team of chemists at the Goodyear Tire and Rubber Company, working in collaboration with Standard Oil, discovered that by adjusting the ratio of butadiene to styrene and adding a new type of catalyst, they could produce a synthetic rubber that closely matched the properties of natural rubber. It was strong. It was elastic. It did not crack in the cold or melt in the heat. They called it GRS, short for Government Rubber Styrene, and it was the miracle the nation had been waiting for. By early 1943, the synthetic rubber plants were producing GRS by the ton. By the end of the year, production had reached hundreds of thousands of tons. By 1944, it exceeded the total pre-war imports of natural rubber. America had done the impossible. It had built an entire industry in less than 2 years. The impact was immediate and profound. Factories that had been idled for lack of rubber roared back to life. Tire production soared. The assembly lines of Detroit churned out trucks, jeeps, and half-tracks, their wheels shod in synthetic rubber. The bomber plants of Seattle and Long Beach accelerated their output, no longer constrained by shortages of fuel tank liners and landing gear cushions. The submarines of the Pacific Fleet, once limited by the availability of rubber seals, now prowled the waters off Japan in ever greater numbers. The American war machine, which had been on the verge of collapse in 1942, was now unstoppable. And the Japanese, who had believed that seizing the rubber plantations would cripple their enemy, watched in disbelief as the Americans fought on, not with rubber from the jungles of Asia, but with rubber synthesized from oil, produced in factories that had not existed 3 years earlier. For the German High Command, the American achievement was a source of bitter frustration. German chemists had pioneered synthetic rubber, but Germany's synthetic rubber industry was small, constrained by limited petroleum supplies and Allied bombing. The Germans produced perhaps 100,000 tons of synthetic rubber per year, enough to sustain their military but not to expand it. The Americans, by contrast, were producing nearly 1 million tons per year by 1944, more than enough to equip their own forces and supply their allies as well. British trucks rolled on American synthetic rubber. Soviet tanks used American rubber treads. Even the Free French forces, fighting to liberate their homeland, depended on tires made in Texas and Louisiana. The scale of American production was not just a military advantage. It was a demonstration of industrial supremacy that no rival could match. The soldiers who fought on the front lines did not know the story of the rubber crisis. They did not know about the engineers who had wept in Washington, or the chemists who had worked through the night in West Virginia laboratories, or the oilmen who had reconfigured their refineries to produce butadiene instead of gasoline. They only knew that their trucks kept running, their planes kept flying, and their equipment did not fail. But in a strange way, that was the point. The genius of American industrial power was not that it was visible, but that it was invisible. It worked so well, so reliably, that the men who depended on it took it for granted. A German soldier, captured in France in 1944, was asked by his interrogators what had shocked him most about the American military. He paused for a long time, then said, "Your tires. They never go flat. Ours always did." It was a small detail, perhaps, but it was symbolic of something larger. The rubber crisis of 1942 had forced America to confront its own vulnerability, to acknowledge that even the most powerful nation on earth could be brought to its knees by the loss of a single resource. But instead of surrendering to that vulnerability, America had transformed it into strength. The synthetic rubber industry was not just a substitute for natural rubber. It was better than natural rubber in many ways, more consistent, more durable, more adaptable to specialized uses. Neoprene, one of the early synthetic rubbers, was resistant to oil and chemicals, making it ideal for fuel hoses and gaskets. Butyl rubber, developed during the war, was impermeable to air, making it perfect for tire inner tubes. By the end of the war, American chemists had developed dozens of specialized synthetic rubbers, each tailored to a specific application. The diversity and quality of American synthetic rubber far exceeded anything the natural product could offer. But the story of synthetic rubber was not just a story of chemistry and engineering. It was a story of human will, of the refusal to accept defeat even when defeat seemed inevitable. In January 1942, when the engineers sat in that smoke-filled room in Washington and stared at the map of the Pacific, they had every reason to despair. The odds were impossible. The timeline was impossible. The technology barely existed. But they did not give up. They worked. They invented. They built. And in doing so, they proved that the greatest weapon in America's arsenal was not its tanks or its planes or its ships. It was its capacity for innovation, its ability to solve problems that no one else could solve, and to do it faster and better than anyone thought possible. There is a photograph, taken in the summer of 1943, of a synthetic rubber plant in Texas. The plant is vast, a sprawl of steel towers and pipelines stretching to the horizon. In the foreground, a group of workers stands beside a railcar loaded with blocks of raw synthetic rubber, still warm from the reactors. The men are smiling, but their faces are haggard, lined with exhaustion. They have worked 18-hour shifts for months, and it shows. One man, an older engineer with wire-rimmed glasses, holds a piece of the rubber in his hand, turning it over as if he cannot quite believe it is real. He does not know that in a few months, this rubber will line the fuel tanks of a B-29 bomber flying over Tokyo. He does not know that it will cushion the landing gear of a transport plane evacuating wounded soldiers from Iwo Jima. He does not know that it will seal the hatches of a submarine sinking a Japanese supply convoy in the Philippine Sea. But he knows that it is real, and that is enough. The Japanese had believed that by seizing the rubber plantations, they could strangle American industry. They had believed that the United States, for all its wealth and power, was dependent on resources it did not control, and that dependency was a weakness that could be exploited. They were not entirely wrong. America was dependent on rubber. But what they failed to understand was that dependence could be overcome. What they failed to understand was that American ingenuity, backed by American industry and American resolve, could create resources where none had existed before. Rubber did not have to come from a tree in Malaya. It could come from a refinery in Texas, synthesized from oil, shaped by chemistry, and produced in quantities that dwarfed anything nature could provide. By 1945, the United States was producing more than 800,000 tons of synthetic rubber per year, nearly matching the total world production of natural rubber before the war. The industry employed tens of thousands of workers and consumed a significant portion of the nation's petroleum output. But the investment had paid off. American forces in Europe and the Pacific were fully supplied. The logistics of war, which in 1942 had seemed so fragile, were now robust and flexible. And when the war ended, the synthetic rubber industry did not disappear. It continued, adapted, and grew. Today, more than half of the world's rubber is synthetic, and the technology pioneered in the desperate days of 1942 remains the foundation of a global industry. There is a lesson in this, though it is not one that can be easily summarized or reduced to a slogan. It is a lesson about resilience, about the capacity of free people to innovate when their survival depends on it. It is a lesson about the power of industrial democracy, the ability of a decentralized, competitive, and open society to mobilize its resources and solve problems that centralized, authoritarian systems cannot. The Japanese Empire was powerful, but it was rigid. It could seize territory, but it could not create industries from nothing. Nazi Germany was technologically advanced, but it was constrained by ideology and resource scarcity. The Soviet Union would later prove capable of immense industrial feats, but only through coercion and central planning that stifled innovation. America, for all its flaws, had something the others did not, a system that rewarded innovation, encouraged risk-taking, and allowed individuals to pursue solutions without waiting for permission from the top. The engineers who wept in January 1942 did not know they would succeed. They only knew they had to try. And in trying, they discovered that the limits of possibility were not fixed, but could be pushed, stretched, and sometimes broken entirely. The rubber synthesized from oil was not just a substitute for the natural product. It was a symbol of what human beings can achieve when they refuse to accept defeat. It was a symbol of abundance, not the abundance of nature, but the abundance of invention, of the endless capacity to create solutions where none had existed before. In the years after the war, William Jeffers, the man who had led the synthetic rubber program, was asked how he had done it. How had he built an industry in a year when everyone said it would take 5? How had he overcome the technical obstacles, the bureaucratic inertia, the resistance of industry, the sheer impossibility of the task. Jeffers smiled, and his answer was simple. We had no choice, he said. We had to. And then, after a pause, he added, but I'll tell you something. Once we started, once we committed to it, we discovered that we were capable of more than we ever imagined. That's the thing about Americans. You tell us something can't be done, and we take it as a challenge. The synthetic rubber plants still stand, some of them, in Texas and Louisiana and West Virginia, though they have been modernized, expanded, integrated into the vast petrochemical complexes that line the Gulf Coast. The technology has evolved, but the principle remains the same. Rubber, once a gift of nature, is now a product of human ingenuity. And that transformation, born in a moment of crisis, remains one of the great untold stories of the Second World War. It is a story not of battles or generals, but of chemists and engineers and oilmen who turned despair into determination, and impossibility into reality. It is a story that proves, perhaps more than any other, that the greatest weapon in war is not the one that destroys, but the one that creates. And so, when you see a tire on a truck, or a seal on a submarine, or a gasket on a jet engine, remember this: it is not just a piece of rubber. It is a testament to the men who refused to give up, who wept in a room in Washington and then went out and changed the world. It is a testament to the power of free people to solve problems that tyrants cannot, to innovate in ways that command economies never will. It is, in the end, a testament to the idea that democracy and abundance are not just political ideals, but practical realities, forged not in the halls of government but in the laboratories and factories where ordinary people do extraordinary things. The rubber that saved America in 1942 was not a miracle. It was a choice. And the fact that it was synthesized from oil, created where nothing had existed before, is a reminder that the resources we need to survive and thrive are not always given to us by nature. Sometimes, we have to make them ourselves.